empresa Saildrone e presidente da Sociedade Hidrográfica da América, SOA. Possui, desta forma, sólida expertise em hidrografia e mapeamentos cartográficos. Mr. Brian Connon, on behalf of SP Hydro, I would like to thank you for sharing your expertise in hydrography and, in particular, remote surveying with unmanned surface vehicles. I would like to inform that the chat can be used for questions, which will be answered at the end of the presentation. Unanswered questions will be forwarded to Mr. Brian. Please, Brian, the floor is yours.
Bom dia, thank you very much. It's great to be here. I see some familiar names in the chat as people are logging on, so good to see all of you that I've worked with in the past. Again, I'm Brian Connon. My background, U.S. Navy hydrographer, oceanographer, worked on the IHO's capacity building subcommittee with a number of the Brazilian hydrographers as well. I taught at a research center at University of Southern Mississippi after I retired for a couple of years, and then I joined Saildrone about 4.5 years ago, so late 2020. So I'm the VP of Ocean Mapping, and my goal here today is to kind of inform you not just about Saildrone, of course, but also just about USVs in general and the benefits and the challenges that we have with those operating those vehicles. So at Saildrone, we are, we believe that being able to sustainably explore and map our ocean is really key to making our planet healthy and keeping it healthy. With the Earth being covered by 71% water, and we've only mapped 25% of it, the whole world really functions on how well the ocean is doing. And I know that you all understand that as well. Now, for Saildrone, we have been around quite a while, and I'll show you a timeline here in a minute, but we are not a research and development activity. We are operational, and we operate around the world, and we're doing a number of different missions to collect ocean and atmospheric and climate data and maritime security data. And again, I'll talk through those in a little more detail as we go through. So these are our three kind of business lines. So up at the top, defense and security. The ocean, as we all know, is so large, it's very hard to monitor it, every piece of it all the time. And of course, anyone who's trying to do something nefarious on the seas, such as drug trafficking or human trafficking or illegal fishing, they know that that is a weakness as well. We can add more eyes and ears on the ocean by having our vehicles out there. Down at the bottom, the ocean research. This is how we built the company, doing ocean and climate and weather observations in very remote parts of the world. We've done fishery surveys, so measuring biomass to help determine fish stocks. And we've even helped with folks like NASA to validate what their satellites are seeing by giving an in situ measurement. Now in the center, the thing we're all really talking about here is ocean mapping. And so we're going to go into that and into a lot of detail, so I won't stick on it here too much. Our headquarters is in Alameda, California, which is across the bay from San Francisco. We have a small ocean mapping headquarters in St. Petersburg, Florida, and a business office up in Washington, D.C. We do use American manufacturing to build our hulls and our wings, and you can see the locations there. And we're globally deployed every day. So I mentioned the timeline. So back in 2013, when our CEO and founder, Richard Jenkins, built the company, over on the left, you can see the small, very first Saildrone that he, a year later, launched from San Francisco, sailed it to Hawaii successfully. And so that was the very first start. But over the years, we worked a lot with NOAA here in the US to validate all of our MEDOC sensors and design wings that would handle hurricanes. So we do drive into hurricanes and measure inside of a hurricane. Then we started doing ocean mapping, and then we got into the maritime security piece to get to where we are now. So a long road, over 10, 12 years to get to where we are today, but very much worth it. And I'll go into some of the actual missions we've done here shortly. So just to kind of elaborate on the fact that we've been at sea for over 60,000 days, over 2 million nautical miles sailed. And, our focus has been on identifying the sensors that are what the customers want, and then ensuring that we've got that data quality. Now, our endurance, because we are a sailing platform, we have much longer endurance than other USVs you will see out there. And that is really what sets us apart. So our Explorer Saildrone, which is a 7-meter platform, the first one that we built, we built 100 of those. Those can stay at sea for up to 12 months. The two larger platforms, the Voyager, which is 10-meter, and then the Surveyor, which is a 20-meter platform, they can stay up to and beyond 60, up to 90 or 100 days, depending on how much we have to use the engine on board. We are very seaworthy. We've operated in the Arctic, the Antarctic, the Northern Pacific in the winter, into hurricanes. These are very durable vehicles. And again, they're, because we're using a wing to sail, we really are a low carbon solution. And I'll mention that in a moment as well. So I mentioned everywhere we've operated. I'd like to point out our Antarctic circumnavigation. That was back in 2019 during the winter. That was 196 days for one vehicle to circumnavigate Antarctica. We have been into the Mediterranean. We have been out to the Western Pacific, and we're operating in all those places today as well. So why would someone use an uncrewed vehicle? First, as I mentioned, they are environmentally friendly. There's a lot lower power. Many USVs are battery only, and so they may not have the endurance that we do, but they are very environmentally friendly. They are efficient. By focusing the USVs on the mission that it's going to conduct, you're not having to worry about having the people on board. You can design it to be much more efficient, and you can build a lot of them for a cheaper cost than you can build a ship. The reduced risk piece is really kind of key. If we're not putting people on the ocean, then we're not putting them in harm's way. And so you really are improving safety for your folks by using uncrewed systems. I mentioned the persistence, being able to stay out there for a long time. And then over on the right-hand side, the ML enabled, so machine learning enabled. So we are able to run machine learning at the edge on the platform to do a lot of the processing of camera data, radar data, and some of our bathymetry data as well on board the vehicle to accelerate that timeline of getting actionable information from the USV. Now, the real-time data access, when I first came to Saildrone, we were using Iridium, and it was very slow and it was painful. Now on our two bigger platforms, we're using Starlink, and it really is a game changer for moving large pieces of data from the vehicle back. So every hour we're moving full resolution raw multibeam data from our vehicles back to our processing cloud. So we can stay on top of data quality and processing in almost near real time. I mentioned the CO2 emissions. So we did a mission back in 2022 going up to the Aleutian Islands, and we compared that to had a NOAA survey ship done that, which has a known engine and fuel burn rate. And at the end of all this, we avoided about 97% of the carbon that would have been emitted by a traditional survey ship. So it really is an environmentally friendly way, and ships are not getting less expensive. And it's, but ships are needed to do some specific things, whether that's AUV operations or ROV operations. And so in this example, we actually mapped, and then the next year, NOAA sent the Okeanos Explorer up, and based on our data, they targeted their ROV dives and were able to maximize their deployment without having to do all the mapping. So mapping using USVs is now normal. And I think it allows you to get more money out of that ship because they don't have to map anymore. Now, our mission portal, this is how we communicate what's happening with our customers. So as a customer, you would be able to log into the mission portal in your mission. You would see where the USV is operating in a geographic format. And over on the right-hand side, there's a time series of data. There can be photos in there. You can see the data from the multi-beam sonars, from the positioning system. And the big thing really is this is also how we communicate with our customers, and it's all secure in the cloud. There's no missed email, there's no missed text or phone calls. Everything is handled within the cloud, and the customer can talk directly to the pilot and the hydrographer on watch. We found that our customers really like this. In the commercial world, if you're on a ship, a customer representative might be on board. Obviously, with the USV, they can't be on board, and we found that they're pretty comfortable using the mission portal in place of actually being on board the vehicle. So as we talk about ocean mapping, we can do everything from the deep sea and into shallow coastal waters, as well as doing sub-bottom profiling in shallow waters. And I don't need to tell you what that data gets used for, but we really kind of focused on what were the best sonars from our perspective that met customer requirements, but also provided us with low power, compact size, all the things that a USV manufacturer has to worry about. And we've been working a lot with both Kongsberg and Norbit to evaluate how they design and build their sonar systems now too. And they're starting to realize that there are actually more USVs now than there are ships, and maybe focusing the development and design on first on using the system aboard an uncrewed system would be better than focusing on having on a crewed ship. We're used to being at sea, sitting in front of the computer, being able to run down and wiggle a wire or reset a card. USVs don't allow you to do that. And so it's really been nice to see industry kind of take this idea that USVs are the future and start redesigning their platforms, their hardware and software to be usable first by USV, because then it will work on a ship. So getting into the specifics of our vehicles, this is the Voyager. I mentioned before, it's 10 meters long. It has a 2-meter draft, and this one has an electric motor on board. And right now, we're averaging about 100 days between having to do service stops to service that electric motor. We have the Norbit IADS winghead, and we have both the 400 kilohertz version and we have a 200 kilohertz version. Has an integrated POS-MV Ocean Master. We're also doing Marine Star corrections. We worked with AML Oceanographic to develop a CTD with inductive charging so that we don't have to run power to the CTD itself. It comes up into a cradle and inductively charges, connects to the Wi-Fi, and offloads that sound velocity profile. We have 400 meters of winch line on there, and the sonar is rated to about 300 meters, so that works out nicely. As I mentioned before, we do have Starlink and the option to put a sub-bottom profiler on there. From a navigation and collision avoidance standpoint, we have multiple GNSs on board for positioning. We do run AIS. We have a Teledyne pan tilt zoom FLIR camera and a Furuno radar, and a ton of algorithms built into the system that alerts the pilot if there's a collision situation approaching. Very safe platforms. The pilot has essentially a virtual bridge that they can watch for this, and really a great platform to work on. So just a kind of a close-up of the installation of the Norbit there on the left, and then on the right to give you a perspective of the size related to a normal sized person. This is us launching the Voyager down in Florida, as we're doing some mapping off the coast of Florida right now. Next is the Surveyor. So 20 meters long, has a 3-meter draft. This one actually has a diesel engine, Yanmar straight marine diesel engine, essentially with generators to power to charge the batteries. Mapping speed right now is if we're under motor sail, it's between 6 to 7 knots. Under sail, it's about 4 to 5 knots. Very quiet platform, and the sensor suite on board is fully Kongsberg with the EM304 Mark II, which Kongsberg says can go down to 11,000 meters, which we have not yet proven. And then the EM2040 for our shallow water work. Again, the POS-MV Ocean Master, the same AML CTD, same Starlink, and this one has a Pinnacle ADCP. This is a little bit of an older picture. We've actually upgraded the radars on these platforms to a 200 watt radar, rotating radar, so much further range for that radar. But again, the same navigation pieces as well. Just to give you an idea of the gondola that the sonars are installed in, that was actually one solid piece of aluminum that was machined at Austell, USA to fit the transducers. Really kind of an amazing thing to watch that. And again, on the right, you can get a perspective of how large this is related to people on the pier. And this is us launching one of these out in Guam in the Western Pacific to do some work for the U.S. Navy. So for this crowd, asking the question why we map, I know that you all know why we map. That's what we do. But when you look at what Seabed 2030 is trying to educate the rest of the world, they kind of break it down into these 6 things. And really, for national hydrographic offices, really the focus tends to be on safety of navigation and updating charting, but it can support so many other things, as you know. So our data can be used for modeling. It can be used to identify marine habitats. It can be used to look for placement of offshore energy, a whole host of things for why we need to map our ocean. But there are some challenges out there. There are limited assets. There aren't that many survey ships, and they are expensive to own, to build, to own, to operate. And it's generally, they're going to be focused on that kind of high priority work. And so approaches, ports and harbors, generally for national things. And as we know, the data keeps getting more dense, and it's large files, and the ability to be able to store all of that and move it around and analyze it, get it out to the users who need it, is a very expensive proposition as well. So it's really how do you get the funding for mapping? And I put in there, it's not trivial. The idea is governments will allocate funding for the priority things they need to do, but there's so much more that needs to be mapped. I'll show an example in a second of how to do some mapping with outside funding. But again, on the commercial side, every industry is looking to do mapping and push money here. But that, again, goes back to the first bit of having the right number of assets. Are there ships available? And USVs are helping to mitigate that lack of capacity by providing a solution that can be built very quickly. USVs can, for the Voyager, the mid-size platform, we can build one of those a month. For the bigger ones, the Surveyor, that's a 2 to 3 month build, which is still way faster than the 4, 5, 6, 7 years it takes to build a ship. You can build many more USVs and have that capacity much, much sooner. The regulatory environment, I know there was a question, I think, when someone asked what I was going to talk about, what are the regulations for using USVs? And I could tell you it's different in every country, in every port. People are either excited to see the technology and are happy for it to go out, or they're very afraid of it. And they hear the word autonomous and or uncrewed or unmanned, and they think, we're going to be out there running into things. Honestly, as hydrographers, we have a very specific mission. We are running lines. We are always watching the vehicle and watching around us. I would say, ocean mapping USVs are probably way safer than most merchants that are out there on the seas right now. But they're becoming more and more accepted. And so I took a look at some of the regulations coming out of Brazil regarding these. And I'd like to probably talk to someone about that, because I see some areas where it could be restrictive. I think we want to be in the regulatory space. We want to be willing to accept a little bit, maybe perceived risk, to not squelch innovation. We don't want to keep companies from not using these, because it just delays the important work that needs to get done. And so we have to work with every country we're going to and determine what their regulations are. And as I say, they're range from no problem to no, there is no way you're going to bring that into our waters and use it. So, but the absolutely nots are decreasing. We're not seeing that as much now. So just wanted to give you a kind of a close case study of what we're doing. Is we're working in the Cayman Islands right now. This was funded philanthropically by someone who wanted to give something back to the Caymans that would be useful for years to come. And so they asked us to map the Cayman Islands EEZ. The data is going to the UKHO for processing. UKHO is the primary charting authority for the Caymans. And so they'll be updating all the charts and also providing all of that processed data to the Cayman governments, to their land survey division, to help them with other things, identifying fishing banks, looking for undersea cable routes, anything they need to use that data for. And so this was really exciting for me to be involved in, to see this much effort funded for a small island developing state that can now understand and know what they have under the water and what marine sources they might want to protect or exploit, and that's their call to do that. So as I always say, no ocean mapping presentation is complete without pretty pictures. So here are just some high-res snapshots of what we've done up there. And as of kind of last week, this was how much we had mapped. The gray areas here were previously mapped, so we're finishing up in the purple and yellow areas, and we should be done with that at the end of August, early September. So to kind of wrap up and not take all of your time this morning, USVs are showing up across multiple markets in for mapping and many other purposes. So not only national mapping, but in energy, whether it's oil and gas or offshore wind, providing survey data, being used to provide METOC data. We're doing a paper next month to show a project that we did with Meta to demonstrate our capability to map for undersea cables. So deep water undersea cables, kind of the 1,000-meter contour and deeper. Again, finding ships to do those is problematic. So Meta asked us to demonstrate that capability, which we've done. Marine minerals become more and more important every day. Certainly here in the U.S., the president's passed an executive order to start really looking at the marine minerals. And so the initial reconnaissance and exploratory mapping for that is certainly something a USV can easily do. And again, to pinpoint those areas, you want to go back with a higher resolution system like an AUV or ROV. And then maritime security. And this is where the majority of our mid-sized vehicles are working in this space, both around the U.S. and overseas, with the cameras and the radars. We're doing missions from counter drug in the Caribbean to counter illegal migration up around Haiti, trying to convince Haitians not to get into small leaky boats and leave. Really any mission that requires you to be able to see what's happening on the water. We're doing those right now. And then there are more defense missions. So think about USVs towing arrays and being able to contribute to undersea warfare. So really it's, the government industry. So, we work a lot with our government and other governments to try and accelerate and smooth the adoption of USVs. So helping with the regulatory piece, helping them understand that we are not just, allowing these things to run around without someone watching them. For us, really the only autonomous piece is the sailing. So we give waypoints and corridors, and we have sailing logic that allows it to sail itself along the path we've given it. So it's really a remote control. So a person's always watching. And then, one last thing on our data as a service model. So we don't sell these drones. We build them, we operate them, we maintain them, and we provide the data at the end to the customer. And so there's no, big upfront investment to build a boat or a USV, to pay for operations and the maintenance and the refueling and all those things. That's all on us. And then at the end of that, we deliver data to your specifications. And again, as I mentioned, that mission portal is how you stay on top of what we're doing and ask us to make changes or adjustments to the survey plan or whatever mission it is. That's what I have. I have one question already from Marcelo about the storm. The sail is not retractable, but we are able, with the surveyor, we've surveyed into sea state 6. If it gets stronger, we'll either leave the area or go into what we call a storm hold. In a storm hold, we basically put the winds on the stern and can ride the storm out. And again, very durable platform. It has a wave-piercing bow. But we also have a lot of very expensive equipment on board. So, we're not going to, for the bigger boats, we're not going to wait for a hurricane to run over us. We will move out of the way there. But the nice thing is, if it is something we can ride out, we can get right back on mission as soon as the storm is passed. The reason we can do that is through Starlink, we're monitoring the data quality, and we can determine at the point where the data quality is just not worth staying on survey, and we are able to get right back on it as soon as conditions allow. And whereas a ship would generally depart the area because of the people on board, we can handle a lot rougher seas than that. Okay, I am open to more questions. Hey, Nicholas.
Nicholas will write to you in the chat to ask a question.
I will take a moment to say, I appreciate what the Hydrographic Society is doing here. As I'm president of THSOA, I know how much work goes into putting these things together to do these technical talks. So well done to the Hydrographic Society there in Brazil for doing that. All right, the question is, how do we run line keeping? So basically, it is the same as you do on a survey boat. We put in the lines and their waypoints. And again, that corridor I mentioned, will make it very tight with the appropriate line spacing that the sonar needs. And the Saildrone will sail those lines and not deviate. Yes, we can stop at a station and recover data from subsea sensors on the floor. And it's that's a mission we've done in the past. And we just demonstrated it again for the U.S. Navy. The daily costs. Without a non-disclosure, I will give you ballpark numbers. So from a mapping perspective for the Voyager, and this will be U.S. dollars, the Voyager, depending on the complexity of the job and whether or not we're doing the processing, you're in the $8,000 to $10,000 a day, and for the bigger boat, you're in the $25,000 to $28,000 a day. Collision avoidance. So the radar, the AIS, all of that feeds into our collision avoidance algorithms. The first thing is, if there's ever any indication of a collision, the pilot is alerted through alerting algorithms. And in some cases, if it is a high enough, risk of collision, it will phone him. It will give a phone call to the pilot just to make sure they're seeing it. But it's if the boat can avoid itself, but generally we will take much earlier action The problem we run into is we'll avoid a collision, let's say an hour away, and then it keeps coming. And then we realize they're coming to take a picture of the drone because they haven't seen one before. And so they keep creating collision situations for us, which is fairly annoying. But we're installing VHF over IP, so we'll be able to talk to ships around us as well. And so I think that's going to be help us a lot too. Or we can just say, hey, are you coming to take a look and take a picture? Then we'll stop avoiding a collision. Arthur, for your question, I think that really depends on the modems being used as far as the depth limit. So, we could have put whatever acoustic modem on these platforms that we want, and that would is really the sensor in the modem itself on how deep we could recover data. I know something like the Teledyne Benthos. I mean, those are 6,000 meters, I think, that you could go down to. What we demonstrated a couple of months ago was a Sonardyne Micro Ranger 2, which is a pretty standard one for USBL and other acoustic things.
Brian, I
Yes.
think there is no more questions.
One more question.
Just a moment. There is one more question. Just a moment.
So we have no restriction on how far away the USV can work. There really is no base station. So I didn't explain how we launch and recover these. So for the Voyager, we ship it in a 40-foot container to the closest port to the area. We send a team down to meet it. We pull it out. We put it together. And we do testing, get it in the water, do testing, and then we escort it out of the harbor, and then it's off to do its work. And that team will then depart and go back to, or go on to the next one they need to deal with. So depending on how far away the operations area is, then the vehicle will sail out there, do its work, and if it needs to come in to refuel, it would come back to that port and then go back out again. So we would have a team that would meet it, do the service, and then that team would fly out again. So we don't maintain any kind of a full-time presence in a port or on a pier once we launch them. Raphael, drop me a note and we can talk more about minimum contract value. And Marcelo, for the fast accuracy of the USV operator. So the accuracy is exactly what you would get. These are off-the-shelf sonars. We do go a little slower than ships. So I like to say we get a higher data density. But it is, again, when you're looking at a ship doing 8 knots, for the surveyor, if we're doing 6 knots, it's not that much different. A Voyager doing 4 knots, so about half as fast. But like we're doing in Florida, we have multiple vehicles on the mission. And so you make up for that lack of speed by having more than one vehicle out there. And that also offers some redundancy. If one vehicle has a problem, you still have some, an asset that can continue, finish the job. Nicholas, policies are never easy anywhere. There's always some issue, but I think it's, so we worked in the Caymans with their port state control officer. So he's, the guy that does vessel inspections and approvals and flagging. And he's part of a IMO group on MASS, the Marine Autonomous, I forget what that stands for, but so he's really pushing and publicizing what he's done. And so I think that's going to be helpful. And a lot of times it just comes down to a conversation. A couple of years ago, we were having trouble getting AMSA in Australia to agree to what we're doing. And our founder, our CEO, was born in Australia. So finally, he just flew down there, and he and the other guy, they went out and they had a pint of beer and talked through what we do. And the guy's finally like, oh, okay, I get it now. So again, I think it's just an understanding. And it's really, I think, on us as the hydrographic societies, the industry, to bring this up to the government to say, hey, this is a real capability that can benefit you. So don't make it hard for us to use these vehicles. And, places, I'll say in the UK, the MCA there has made it hard. They've tried to adopt a workboat code to USV operations and really made some decisions that are getting fixed. So, hey, Alberto, good to see you. Well, sort of see you. Any vetoing process by the U.S. government while operating in other countries? So are you saying if we went to work in another country, could the government come and tell us we can't work there? Is that what you're asking? We have not seen that yet, but there are certainly some countries that we would not work in, just for risk to our people and to our vehicles. Raphael, yes, we have done some marine studies. Generally we're just providing the platform for the sensors. If you go to the Saildrone.com, our website, there's kind of a history of those missions that we've done, looking at that. One thing we did on the Aleutian survey, and we haven't done it since, but we carried an eDNA sensor from MBARI, the Monterey Bay Aquarium Research Institute. And that was really kind of interesting because we collected and held on board 60 samples for eDNA, which then they came back and processed and wrote a lot of papers on. I think that kind of technology is going to be kind of key moving forward. Again, when I talk about that edge processing, if we can get to the point where eDNA can be processed on board the vehicle, rather than holding a sample that has to be offloaded, I think that's really going to be something for marine diversity that's going to be really, really interesting to watch.
Well, Brian, I think there is no more questions. I would like, on behalf of Admiral Augusto, President of Veículos, to thank you. Your disposal to make us a presentation, and thank you very much.
Yeah, it was my pleasure. Thank you to all of you. Alberto, I'm going to reach out to you because I'm going to be in Portugal next month, so maybe we can get together. Thanks, everyone.
Thank you. Bye-bye.